Alrighty, welcome to STA 3032 Intro to Python videos. We're going to jump right into video 09 Essential Operations with Data Frames. These last three videos in this intro series, so Essentials, the summary, stats from data frames, and data aggregation, are going to start getting really heavy into the statistics side using pandas, which is the tabular form of the data that's used in Python. So let's go ahead and look up pandas. Oops. Python, and let's just go ahead and see what pandas is. So pandas is an open source providing high performance, easy to use data structures and data analysis tools for Python programming language. So that's exactly what we're doing in this class. We're using Python to do data analysis and summary statistics. So pandas is really where we're going to do the majority of our analysis. So this is going to be the heart of really what we're going to do in this class. We'll go ahead and launch video, our notebook 9 in your Jupyter notebook. We'll go ahead and restart and clear all the outputs. So we'll start with a fresh thing here. This first line, again, all this gives us is our IntelliSense. So if you don't type it in, you don't have to run this one. But this just gives us help later on when you're stuck on, can't remember what the method was. You can start typing it and then hit the tab button and it should complete it for you. So let's go ahead and get an example of that here. If we know it was read something, right? For instance, type READ and you hit tab, it'll give you all of the different read methods that it has. So you can see you can read from SQL, you can read from CSV, which is what we're trying to do. So we'll go ahead and read our data folder /data.csv. And so let's start now. Let's go open up our Explorer window. Actually, let's start a new one so you can see the process here. But go ahead and open up an Explorer window. It's going to navigate to our Python install, so where our WinPython is installed for Windows users, and Anaconda for people on Macs. For Windows, it's C program files where I installed mine. You can install it in another location, but I installed it in C program files WinPython. All my notebooks reside in my notebooks folder, and we're doing the intro to Python. So there's my all my intro to Python notebooks. IPYNB stands for IPython notebook. So these are the actual notebook files. So you see that's the one we're running right now. And I have a data directory. Inside that data directory, I have a bunch of different data files. And I used these files earlier in a video where we talked about importing data into Python. So that's what we're going to do now. We're going to use the read CSV, and it takes a relative path. So our Python notebook is in this directory here. So relative path would be data directory and then our data.csv file. All these files are located on the web courses in the files section. So you can go ahead and download all these files as well. We'll look at this one here is the one I'm going to be using for this series of classes. So let's go open it up in Excel so you can see what it looks like. But in Excel, it just opens it up as a regular Excel file, although it's a comma separated value. So if you open a notepad, you'd see it'd look a little different. But this is how Excel treats it. It's got columns, column headers. So that's our column headers, the names, and then these individual rows of data, 2, 3, 4, 5, are the actual contents that we'll be loading into the CSV or into the Python. So let's go ahead and do this most simplest load. We imported pandas PD, so we do pd.readcsv and give it a relative path to the file we're trying to load, and then we're going to go ahead and print it out. Data. There you go. We have our, just like we saw in Excel, it's our table data, but the only difference is we have this extra column here, and that's our index column we learned about last video. So more to come on that in the next line here. So we can tell pandas that a certain column is going to be our index column, and it's 0 based. So this is column 0, this is column 1, column 2, column 3. So we're saying column 1 here, right? So we're going to import the exact same file, but an overloaded method for read CSV. You can do index_call for column, and you can set a value. So in this case we're setting 1, so we're going to set this column here to be our index column. Let's go ahead and look what that looks like. So what that did is, you can see how it's separated just a little lower than the rest of the columns. That's our indexing column, so that's going to be our column index. This line of code here, that was from a previous example. Alright, so now you can, that's the way to do it natively, by pulling in columns. Now if you want to give them your own column names, in this case we're going to call it ABCD, you can import the data, and then there's an index method on the data that you can go ahead and give it a Python list that'll give it its column name. So we run that, you'll see that it's now our same table data from the data.csv file, but our column names are these indexed columns, so A, B, C, and D. And these are names you can give them whatever you want. I think last video we did test. So if we run that now, you'll see that we have a test B, C, D. And we can actually re-index things. So let's go back and now use a series example. So Python series was the one-dimensional array. So when you have a two-dimensional array like a table, you would go ahead and use the data frame, but when you only have a vector or a one-dimensional array, you can go ahead and do it as a series, and you can give it, you can define the index right in your series method. So we're going to define our series data as 3, 1, 2, and our indexes as B, A, D. So this B is going to correspond with this 3, this A will correspond with the 1, and the D corresponds with the 2. So let's go ahead and run that. So we create a series, a Python a pandas series. So now you can see our BAD. You can re-index things. There's a re-index method. Now all these methods that we're going over here kind of get into the weeds of Python, and probably won't be required for any of the Python assignment. So this is really kind of in the weeds of what you need to know, but I think it's kind of important if you want to have a better grasp of what's going on underneath. But really, for all intents and purposes, the data that we're going to have is going to come in a table format that you'll just read in this way. You're not going to have to rechange the series, you're not going to have to change the indexes, but it's there. I want to kind of go over it so you understand how to do it. So we're taking our data, we're going to create a new variable called new data, and we're going to assign it a re-indexed from our data A, B, C, and D. Well, if you look up here, in here, there is no C. So C is going to be, does not exist in our data. So what is it going to map it to? We'll see in a second. But you'll remember A is mapped to 1, B is mapped to 3, and D is mapped to 2. So when we re-index, alright, we get our 1, 3, and 2, and our NaN, or our not a number, is assigned to anything that you've indexed that doesn't exist in our series, or for that matter in a data frame if it was in a data frame. So anything you try to re-index to something that doesn't exist, it'll disappear, or it won't have a value. It'll be called not a number. Applying a function. So now we need to get into a little bit more complex stuff where you can actually manipulate the data. If you need to take the log normal of the data, or you need to take the inverse, sometimes you need to run it through some math function. So if you have inches, you need to convert it to centimeters, that kind of stuff. So this is how you would do type conversion, or from one function to another function. Again, we're going to create a simple data frame. So we got 2 rows of data, 4, 36, 1, and 9, 25, 16. We're going to create 3 columns. The columns are going to be A, B, C. So 4 will be A, 36 will be B, and 1 will be C. And then we have our indexes. So the first row will be assigned red. The second row here will be assigned blue. And this is how you create a manual data frame. Again, in the real world, you're going to be pulling in CSV files. And for the Python assignment, I'm going to have you be pulling in data from an external file as well. But you can hand jam everything in if you want to be tedious about it. You can actually type in everything. But you get a data frame that has three columns and 2 rows, and these are our indexes. So if you wanted to say data of red, actually let's do red. Oh, that gives us a location. There we go. I forgot to add. Remember, you got to add the method location, and you'll see it has A, B, and C. So this gives us back a Python series, not a data frame. When you do the location, and you give it a row. That's just a reminder from last lecture, or for the last video that I ran. Now let's import NumPy, and we'll learn how to do things like run NumPy the square root of the data. Sometimes we need to take data and take the square root of it. So you can just pass in a data frame to a square root method, and it knows what to do with that. So NumPy actually knows how to deal with tabular data in the form of a data frame. And if you take the square root, it knows to go element by element and take the square root of each element. So it takes 4, the square root of 4 is 2, square root of 36 is 6, and so on. But the big difference here is we went from something that was integer data, and now we are in something that's called floating point. So you see it has a decimal place. Even though all of these were perfect squares, if one wasn't, you'd have a decimal place, and when you run it through a square root function, it is going to upcast your data type from a integer type to a floating point type. Let's go ahead and create that as a new cell so I can show you how this works. Alright, this next line here is just a function. What happens here is anything that gets called to double up is going to actually return whatever you pass in doubled. So let's go ahead and create a new cell, and we're going to say double up the number 3. And oops, why didn't that work? Oh, I didn't run it. See how it doesn't have it run, so it doesn't know it exists in memory. So now I've run it, so you see it where it says 15. And when I run double up now, it takes whatever you pass in and doubles it. So let's see if I pass in 2 things, what happens? And it did it as what we didn't want to have happen, because it took it in as a Python list, and it did Python list math here. If we happen to do numpy.array, which we learned about in another video, and close that out. So you see how it's highlighted green here and here? That means that's that parentheses. If I highlight this one here, it pairs it up with that one. So you can see that, make sure that you have your parentheses in order and all correct. But there we go. If you pass in a NumPy array to double up, it does it correctly, where it's going to double the 3 and it's going to double the 2. So that's all it is a function. You pass in something and it returns the double of it. Well, the nice thing about data frames is you can apply a map to it. And what that does is you pass in a function, and it's going to go through and apply that function to everything in the data frame. So it had 4 before, because it went back to this data set here. Let's print out data so we can see it closer. So we're going to go ahead and print data. Then we're going to apply the map to it. And we're going to see the values after. Okay. So we had 4. Now it ran it through the apply mapping, which called this function on each individual element. So everything got doubled. So that's as you would expect. But just like we learned last video, it's not persistent. It doesn't stay because we didn't apply it. If we needed to apply it, we have to run the what was the name of the method? I put it down here at the bottom. In place. Now, I haven't done it on. I don't know if apply map has an in place or not. But no, it doesn't have an in place. So you can't apply in place on a apply map. But if you wanted to, you could reassign it. So this would, when you do it without this assignment, like we just did, it's going to do it and hold it in temporary memory. Here we're taking the temporary memory and reassigning it back into data. So now when I print out data, you'll see that it holds the doubles. So 8, 18, and so forth. So let's go ahead and go back to the original data, so I don't want to ruin our data. So we'll go back to Hughes. Control Enter here. So now you see it says 25. So now let's go here. And let's do a different method. Actually, let's print out data real quick so we can keep track of what's in our data variable. Okay, so now we're going to do another method. And we're going to learn about axes. So that our axis is setting as 0. So now we're going to learn, we're going to make a new method that's going to take in some kind of vector or something, and it's going to return the max minus the min. So let's go ahead and run this. So it's in our memory. So now it says 27. That means it's in our memory. And let's just look at what it would do if we did it in NumPy. So NumPy.array. And let's create a, let's do max. So we'll do 2, 4. So max minus min is going to be, if I run it through this difference, it should be 4 minus 2. So let's see what happens when I do that. So what I've done here is I've wrapped that's our NumPy array that we created. I wrapped that array in our method that we just created up here called difference. And we're going to go ahead and run that, and you'll see that we get 2. If I double this to 8, we should get 8 minus 2, which is 6. So that's all this is up here is a method. We hit DEF, gives us, we're defining something. We're defining the term difference that takes in one variable x. Oops. It takes in one variable x and returns the max minus the min on that. So now, going back to our data frame, we've learned that there's an apply method that we can apply, and you pass in a method. So data.apply, and then we're setting our axes to 0. So now what that did, when our axes is 0, it's going to go down the columns and do column-wise. Our axis 0 is column, and our axis 1 is row. So it's going to take 36 minus 1 to give us 35, and 25 minus 9 to give us our 16. So setting the axes is going to tell you whether you're going to do it column-wise or row-wise. Axis 0, column. Axis 1 is row. So I never remember which one's which, so what I typically do is I'll do a simple example like this and then run it 0 and see what I get, my results, and then I'll go back through and actually set the axes correctly on the data that I'm going to play around with, that I'm manipulating. We're almost done with this video. 3 more sections. This video is probably going to be a little longer than the rest, but it's probably a lot more complex of a topic. Alright, so now we're going to go on to sorting the data. Let's just print out our data that we have, and we can sort it by index. Now, if you remember, our index here we defined as red and blue back when we created the data. So when you sort by the row labels, we're going to do it in default is in ascending order, and it's going to do it alphabetically if the data is a string. So B comes before R, so I would expect that blue would come before red. And so that's what our sorting does. And because it's not persistent, if I re-grab our data again, it's going to go back to red-blue. And that's because we didn't set, what's the thing at the bottom again? Our in place equals true. If you set in place equals true, it may stick, and then blue would always be first, so it would reorder them permanently. Alright, so there, we can also sort on our axes 1, which is funny because default here, axis 0 is rows. This is why I can never remember which one's which, because before axis 0 was columns, and now when you're doing sort index, axis 0, which is what is equivalent of doing this. and that's a sorting by our first axis, which is a row in this case. And now if we do it by column, and you can also set ascending false or true if you want to do alphabetical or opposite of alphabetical. So now we did it by our column labels because it's axis 1, and we did it opposite, so it goes CBA. And this is just when you're printing out tables for charts and stuff from your reports. You might need to sort the data so it looks pretty. You minimize, get out null values, that kind of stuff, and get the table looking nice and pretty. And then you take a nice print screen of that and add that to your paper. But again, none of it's persistent. If I run and print data again, it goes back to the original form ABC in red and blue. And that's again because we didn't set our in place equals true. So if you don't set that, it's going to revert back to what you had before. You can also sort by a particular item. So it'll sort by, in this case, our B, and we're going to sort in ascending. And so you'll see that it put it blue first and then red. Or you can do it ascending, comment this out. And then ascending false, so you want it to go the opposite, so it does red blue. But you can sort by a particular letter. Now you can also sort by the axes 1 in your sort values. Axes 1 again is columns. So when we sorted by blue, so we're going by blue, but we're doing it ascending true, or false or whatever. I guess we didn't leave it in there, so it's true. Then it's going to do axes 1, which is going to do column values sorted. So you'll see it goes A, C, B, and that's because axis 1 is your column. It's going smallest to largest. If I did ascending false, it should go from largest to smallest. Oops, too many commas. There we go. And so now you'll see 25, 16, and 9 based on the blue. And you'll see that it sorts red in the same column order as it sorted blue because we're sorting by blue. If I did red here, now red is the one in charge, so you get BAC, which makes blue out of order. Again, all this is important when you're trying to print out tables to make them pretty for charts. It may be on the assignment where I need to have a particular order. So again, you'll have this as an example to reference back to. So if the assignment does have you want to do some kind of sorting, just remember that you can sort by a particular row, and you can set the axes to 1, and you can set ascending false or true to change the order based on the individual cell data. Now, how do we handle missing data? A lot of times data is dirty, so you'll have values that are just, it doesn't exist because for whatever reason you have a sensor, like an EEG sensor or something, that doesn't get a sample for some time period. So when you get the data, it just has missing data. So let's go back and create a pandas series with some missing data. np.nan is our value that we have here that we've seen in the past as not a number. So we have 1, 2, not a number, 3, not a number. Does not a number equal none? Apparently not, because all of these return back false. So nan does not equal none, which is an important thing to think when you're trying to do, for instance, I want the data. That does not equal none. If I'm trying to filter my data, it's going to give me an empty set. And if I do the opposite, which is exclamation equal sign, means not equal to. So if the data is not equal to none, I want it in my data set here. So that should give me everything, because everything is not none, if that makes sense. That's inverse logic, but that's what I'm doing in a nutshell. In other words, I want to just make sure it's perfectly clear that not a number does not equal none. but it does equal null. You'll see that not a number is equivalent to null. In most other languages, and actually in Python too, there's this value called null, and not a number is overridden for not a number here to mean null. So you hear false, false, true, false, true. Going back here, that's a number, that's a number, that is null, that is a number, that is null. And that's what we're showing with is null. And then we can top the inverse of that by doing not null, and that should basically give us the inverse. And the cool thing with this is I could take data and I can filter it. So I want everything that's not null to be returned. Oops, sorry, click away from that. To return to my data set here. And you'll see that I get 0, 1, and 3. It ignores 2 and 4 because those are null values or considered null values. Now, that's all fine and good that you can filter it out, but and this is basically what I just did here a second ago. But you can also do drop NA. So if it doesn't have data, we're going to drop it, and you'll see that you get 1, 2, and 3, which is exactly equivalent to what I did earlier. There's just a quick method to do the same syntax that I just ran a second ago. This syntax that I ran here makes more sense to me because I'm a programmer and I can clearly see what's going on here, whereas this is just a method that can obfuscate things from me. So I would much rather have, in my code, I would write it this way. So that way I would know what really is underlying, rather than having to go to look to the API documentation to figure out what drop NA is. So how would I do that? I would go to Google, pandas data frame, and then I would look up what drop NA means. And first thing that comes up, look at that, it's actually a deprecated in the newer version. But all it does is determines if a row or column in which this contains the missing value, and it removes them. So it returns the data frames with NA entries dropped from it. So nulls and NaNs are removed. And that's what we saw here. And that's how you would go to figure out if you see a method that you don't understand what it does. Go to Google, type the method in, and give it a more context, like saying pandas or Python or something else, to have it hone in on what you really need. But that's programming is a lot of Googling and reading the documentation. Now, there's different methods for what we do with missing data when we actually have it in a data set. Sometimes you just put in 0 values for it. So fill NAs with 0. You'll see what it did here. Instead of not a number, it put in the value of 0. Which is fine for certain statistics that you're running, but oftentimes that's not an acceptable solution because that'll throw off descriptive statistics on it, or it might even throw off some kind of statistical test that you're running. So there's other methods. Sometimes people will put in the mean of the entire population or the entire sample that you have as the missing value. That way it won't throw off your center of mass on your data. And so you can actually fill NA with whatever you want. So fill NA with zeros is going to fill it with a 0, but you could just as easily fill it with the mean. And the mean is just another method that I should have probably shown you here before. You can just take the mean of data, right? Just Control, Enter, and then it runs it. And you see that the mean of this data, 1, 2, and 3, is the value 2. And so you can fill NAs with 2 by running it just like that. So you see 1, 2, it had the NA here, so it put in a 2. It had an NA here, so it put in the value 2. Or you can specifically fill in different values. We know index 2 had NA, so we want to put 100 for that one. And we know index 4 had an NA, so you can put in the number 500. So when you run that, you can see that you can put in specific values. I could just easily put in 3 and 5, and you see 1, 2, 3, 3, 5. Again, one big note that none of this is persistent. unless you use in place equals true or you reassign it. So if I print it out now, you'll see that I still have my NAs in the original data, but if I do a reassign and I print out my data again, you'll see now it is persistent. So my value of 3 and my value of 5 are now locked in my data until I change it again. So two ways to do that. You can do the reassignment with the equals like that, or you can use in place equals true. And that's it for this video. Just a few more to go.